Ever wondered how much weight does natural language processing, or NLP, holds in our everyday digital life? It might surprise you to know that its roots go as far back as the 1950s. At the heart of the digital revolution, computer scientists were wrestling with a fascinating challenge: how to make machines understand and translate human language. The inception of NLP was marked by the development of machine translation programs. These early programs were basic, converting words from one language to another without understanding context or nuance. Yet, they were a significant step forward. This was a time when the world was in the grip of the Cold War. The ability to translate Russian text quickly and accurately was of paramount importance. In the early days of NLP, the focus was on rule-based systems. These systems were programmed with grammatical rules and a dictionary of words to interpret and generate language. But language, as we know, is complex and ever-evolving. It's full of quirks, exceptions, and cultural nuances that a rule-based system can struggle to comprehend. Despite these challenges, these early efforts in NLP laid the groundwork for the sophisticated language models we see today. The journey was not smooth, and the road was filled with numerous challenges. But every challenge brought a new breakthrough, a new understanding of language, and a step closer to making machines understand human language. And that was just the start of a revolutionary journey that we now know as NLP. As we moved into the 80s and 90s, NLP began to transform. The era marked a paradigm shift, moving away from rule-based systems that dominated the early years of NLP. These systems, while groundbreaking for their time, were limited by their rigid rules and inability to adapt or learn from new data. The 90s brought a revolution in the form of statistical methods, a more flexible and dynamic approach to understanding language. Instead of relying on handcrafted rules, these systems used algorithms to analyze large amounts of data and draw conclusions. This was the dawn of machine learning in NLP, giving birth to models that could learn from and adapt to new information. The introduction of machine learning techniques was a game-changer for NLP. It allowed for a more nuanced understanding of language, taking into account things like context and semantic relationships. Suddenly, computers weren't just following rules to understand language, they were learning how to understand it, much like a human would. Parallel to these developments, the world was being swept by another revolution: the internet. The internet provided an inexhaustible source of data, a vast playground for these new machine learning models to learn from. It also created a need for better NLP systems, as more and more information was being produced and consumed in digital form. With the rise of the internet, NLP was poised to take a giant leap forward. The 2000s marked an era of significant progress for natural language processing. This was the dawn of the deep learning age, a period that witnessed an exponential increase in the capabilities of NLP. Deep learning, a subset of machine learning, employs artificial neural networks with several layers, or deep structures, to model and understand complex patterns. These layers enable machines to process data in a way that is eerily similar to the human brain, making them more adept at understanding our language. The application of deep learning to NLP brought about remarkable improvements in various fields, such as machine translation, speech recognition, and text summarization. Machine translation became more fluent and context-aware, reducing the choppiness that plagued early attempts. Speech recognition systems began to understand accents, dialects, and even contextual clues, making our conversations with Siri or Alexa much smoother. Text summarization tools, on the other hand, became more accurate, digesting lengthy documents into concise summaries without losing the main points. One of the most notable breakthroughs in this era was the development of Word2Vec in 2013. This tool, developed by researchers at Google, changed the game by allowing machines to understand words in relation to other words. It works by mapping each word to a high-dimensional space where the semantic relationship between words is represented as geometric relationships. This allowed machines to understand the context of words, their synonyms, and even their antonyms, making their language understanding much more nuanced. But Word2Vec was just the beginning. It opened the floodgates for more advanced techniques, such as long short-term memory networks and transformers, which took NLP to the next level. The introduction of deep learning brought NLP to new heights, revolutionizing the way we interact with machines. It transformed our devices from simple tools into intelligent companions, capable of understanding and responding to us in ways we previously thought were exclusive to human interaction. The progress made in this era set the stage for the advancements that were yet to come, pushing the boundaries of what we thought was possible with NLP. NLP has come a long way, and today it's more advanced than ever. The transformative power of transformers, no pun intended, took the world by storm in 2017. These models, built on attention mechanisms, revolutionized the field of NLP, introducing a new era of understanding and generating human language. The transformer model, developed by Vaswani and his team at Google, was a game-changer. It introduced the concept of attention, allowing the model to focus on different parts of the input sequence when producing an output. This was a stark departure from the sequential processing of its predecessors, resulting in increased speed and efficiency. In the wake of the transformer model emerged BERT, or bidirectional encoder representations, from transformers. Proposed by Google in 2018, BERT took the NLP community by storm. Unlike previous models that read text input in one direction, BERT reads both left to right and right to left, capturing the full context of a word. This bidirectional approach led to unprecedented success in tasks like question answering and sentiment analysis. But the evolution didn't stop there. In 2020, OpenAI introduced GPT-3, the largest and most powerful transformer model to date. With 175 billion parameters, GPT-3 can generate impressively human-like text. Its applications range from drafting emails and writing articles to creating poetry and even coding. These models, and others like them, have opened up a world of possibilities. They've improved machine translation, making it more accurate and contextually aware. They've bolstered sentiment analysis, allowing for a deeper understanding of the nuances in human communication. And they've enabled more sophisticated chatbots capable of maintaining a coherent and contextually relevant conversation. So, what does this mean for us? It means that we're moving closer to a future where machines can understand and generate language as we do, a future where the line between human and machine becomes increasingly blurred. With the advent of transformer models, NLP has truly stepped into the future. So, what does the future hold for NLP? As we look ahead, we see a landscape where NLP continues to break boundaries and redefine our interaction with technology. Imagine a world where language barriers are a thing of the past, where translation tools are so accurate that they perfectly capture the nuances of every dialect. Picture voice assistants that not only understand you better but can also respond with the wit of a seasoned comedian or the empathy of a close friend. Indeed, the future of NLP is about creating more human-like AI. Machines that can understand, interpret, and respond to human language in all its complexity and diversity. It's about making our interaction with technology more intuitive, more natural. It's a future where machines don't just understand our words, but our intent, our emotions, and our cultural context. It's a future that's not just about better technology, but about better communication. In the world of NLP, the future is always exciting and full of potential. Stay tuned to witness the next big breakthrough in NLP.